look and answer some questions about this quadratic function. First of all, does the function have a minimum or a maximum? Which one? We look at the x squared term, and in front of it, we look to see whether it's negative or positive. We get a negative. Negatives make us frown, so we will have a maximum in this case. So we'll come back for that. Positive value here gives us a smile, which would be a minimum. What is the function's minimum or maximum value? So that is the y value, the y coordinate of the vertex, right? Because this minimum maximum, it always occurs at the vertex. And where does the minimum or maximum value occur? Where? That's a location thing. Anytime we're talking location, we're talking the x value, and that kind of emphasizes it here. Okay, so what we need to find is the vertex is a point minus b over 2a. The y coordinate is you take that number, whatever we get here, minus b over 2a, and we plug it back into the function to get it. So let's find this minus b over 2a. So that's a minus, b is, here's a is -1, b is -10, c is -25, which we don't need for this, but that's okay. We have a -10 here. We have a 2 times -1, which is a. So that's what the x coordinate is going to be. We've got a negative over a negative and another negative, so it's still going to be -10 over 2. 10 over 2. And those negatives canceled, leaving this one. 10 divided by 2 is 5, so -5. X equals -5. So that's the coordinate we get there. What we're going to do is we're plugging -5 into the function, so g of -5. We're going to get -5 squared minus 10 times -5 minus 26. So -5 squared is positive 25, and then this negative on the outside attaches, so we've got a -25. Negative times a negative is positive 50 minus 26. So -25 and -26 give us a -51 plus 50. We're going to end up at -1. So the y value is -1. So we could put that in here. So I'm going to go ahead and enter these. It is a maximum. -1 goes in here. We don't have to have the y equals, and then a -5 goes in here. However, I always like to verify, so we're going to come and graph it. I've already entered in the function, and I'll do a zoom. This time I'm going to do a zoom fit, just to, because, yeah, I don't know. Yeah, there it is, fitting it, seeing it. I see it there. I'm going to go to the window. Y max is -1. Let's make that 20, positive 20, because I always like to see the x-axis. So watch when I graph it, it gives me a little bit bigger view, and I can see 1, 2, 3, 4, 5 at -5. But it's hard to see. It's not, looks like it's crossing, but the other thing I could do is I can go to the table, second table, and I can see at -5, we do have a maximum value of -1. Okay, and then you see it's sort of symmetric on either side, but this allows us, yeah, -5, -1, verify our values. That is the maximum. One more thing, again, if you're satisfied, you can move on, but I want to show you can go second. Actually, let's go to the graph first. Back to the graph. We can do second calc on the graph, and we can calculate, it'll show us graphically the maximum. We're going to find the maximum. We do this by taking our little cursor guy and moving it to the right, or sorry, wrong way, to the left, because we need a left bound. So I have to be on the back side of the mountain. So in this case, it's the mountain. I hit enter. Now it's going to ask for a right bound, so I move my little spider dude over to the right side. I know it's only got 4 legs, but it looks kind of like a spider. We hit enter and enter, and notice it gives us a maximum. We would round this to -5 and -1. So again, a visual way of seeing all of this play out as well. Okay, that's number 8. Just a few more to go.